Okay, so today we're going to be talking about covalent compounds. And just a little bit of a reminder that when we're talking about covalent compounds, we're talking about elements that are made up of things that are nonmetals. And this is because they're on the same team, they're able to share electrons instead of all of what we've seen before, which is ions giving and taking electrons. So these ones have it so that both elements are kind of holding on to the electrons at the same time. And today we're going to be looking at just binary covalence, so we're not going to get into anything too complicated. Just remember co being like cooperate and collaborate. So we're talking about things working together. And then valent because it's the outside electrons that are being shared. So I just want to kind of take a step back and just talk about acids for a second, just so that we don't get those confused. So when we have acids, we're looking at a compound that generally has hydrogen in the front, and then it's either connected to a nonmetal, or it's hydrogen connected to some kind of polyatomic. And while all of these are nonmetals, and all of these are nonmetals, it also has that little AQ there. So with here, all of our elements are nonmetals, all of these elements are nonmetals, but acids are still considered to be ionic. And that's because hydrogen is going to actually separate away from chlorine, and it's going to be an ion. And chlorine is also going to have a charge. It's going to have a charge of -1. And here, hydrogen has that charge of +1, and here, sulfate has that charge of -2. So the fact that they still form ions, even though these are made up of nonmetals, makes this ionic. So we're not talking about acids when we're talking about anything that's covalent. So this is the first time we've been looking at things that are actually just nonmetals that are combined. So the naming system's pretty straightforward. We have a couple of things that we call prefixes. And pre just means that we put them in front of something, and we're going to attach or fix them to the element to indicate how many of each element we have. So we use mono for 1, di for 2. Hopefully some of these will start to look familiar. So you might know the name of a shape that has 3 sides. We call that a triangle. You may not necessarily call a square or a rectangle a tetragon, but that would be the technical term for it. But hopefully you're much more familiar with a pentagon, so a shape with 5 sides, or even a hexagon, something that has 6 sides. A lot of times we're not going to get all the way up to things like octa or nona. So octa I always remember because of octopus. It has 8 arms. Or you might even think about deca as in a decade, which is 10 years. All right, let me move that over for you. So when we're using these prefixes, we just use these words to show how many of each element we actually have in our compound. So let's say that we are looking at something that has 2 phosphoruses and 5 oxygens. Well, we would call something like that di, because di is what 2 means. And then we just add the element name, phosphorus. And we'd call this one penta. And I'm going to just leave that A off, and it'll make sense in a second, because it's 5, and then oxide. So I just left that A off because if you have an A and an O together, we just cut off that A. So it's pentaoxide. Pentaoxide seems kind of strange. So these indicate how many each of our elements we happen to have. Now, there's a little bit of a rule, a bit of a convention. A lot of times we don't happen to mention when there's only one of something. We just leave it as is. So here, we just call this nitrogen. The exception is with oxygen, though. So we always put that mono there with oxygen. I don't know why, but that is the way that we do things. And so we would say monoxide, so nitrogen monoxide, but we wouldn't say mononitrogen monoxide. This might sound familiar if you've ever heard of carbon monoxide, which is 1 carbon and 1 oxygen. And then just pay attention here as well that we still end with that ide. So much like ionic compounds, we're still having that "ide" show that this is a compound and not two elements by themselves. So the way that this is different from ionic naming is that we have these little prefixes to tell us the number of elements, just because we could have different combinations. In ionic, we do not have these little words in front of the elements because there's only one way in which those can combine. And let's just try a one in reverse. So if we happen to be looking at the name and we have dinitrogen, and let's say we have trifluoride. I'm just making this one up right now. Because it's di, I know I'm going to put down nitrogen and then put a 2. And because this is tri, I know I'm going to put down fluorine and then put a 3. So before, when we were talking about those Roman numerals and metallic charges, that told us the actual charge of the metal that came before. But here, these prefixes are telling us the actual number of elements or atoms of that element that we have. Hopefully that makes sense. You do not need to remember these prefixes. You do not need to memorize them. You just need to make sure that if you see them, you automatically know that they're going to be covalent and that you know how to use them. Hopefully that helps out with this little last part. It's pretty straightforward, but if you have any questions, you can always send me an email and we'll talk some more later. Take care.